This video will cover the topic adding rational expressions with different denominators and a single occurrence of a variable. To do this, we find a common denominator for both of our fractions, just as we would if there were no variables involved, and then we add our numerators and keep the same denominator to find our final answer. Let's break that down. Here we have an example of two fractions where one is subtracted from the other one. Normally, when we have two fractions added or subtracted, our first step is to find a common denominator for the two fractions.
How do we find a common denominator of two fractions when there's a variable in the denominator of one of them?
That's a good question. If we just had numbers in these denominators and no variables, we would need to find the least common multiple of both of these numbers. When we have a variable, we need to do the same thing. We need to find what's the smallest number that both 4 and 5y can multiply into evenly. To find this number, let's first find the least common multiple of 4 and 5, ignoring our variables, and then after we find that, we can consider our variables. Some multiples of 4 are 4, 8, 12, 16, 20, 24, and some multiples of 5 are 5, 10, 15, 20, 25, and 30. From these two lists, we can see that the smallest number that both 4 and 5 multiply into is 20. So the least common multiple of 4 and 5 is 20. This is just one of many ways of finding the least common multiple of two numbers. So now we know that 4 multiplies into 20 and 5 multiplies into 20, but 5y does not multiply into 20. However, if we just add our variable y here, now 4 multiplies into this number still, and 5y also multiplies into 20y.
So to find the least common multiple of the denominators, we first find the least common multiple while ignoring the variables, and then we multiply the necessary variables to the least common multiple?
Right. So now we need to rewrite these two fractions using this common denominator. In order to make the denominator of our first fraction 20y, we need to multiply it by 5y. And to keep the value of the whole fraction the same, we'll also multiply the numerator by 5y. For our second fraction, in order for 5y to become 20y, we need to multiply it by 4. And in order to keep the value of this fraction the same, we also need to multiply the numerator by 4. When we simplify these terms, we get 15y over 20y minus 28 over 20y. Now that these have the same denominator, we can keep that denominator for our final answer, and our numerator will be the difference of these numerators, which is 15y minus 28. Since this cannot be simplified any further, our final answer is 15y minus 28 over 20y.
In order to add or subtract two fractions including a variable, we first find a common denominator. Next, we'll rewrite the fractions using the common denominator. After that, we can add or subtract the numerators while keeping the same denominator. At that point, if needed, we simplify the solution as much as possible.
That's right.